Okay, so let's go over some of these. We did some of these in class. I want to look at number B on the stretch, okay? So this is that inequality sheet that looks like this. It says 3 is less than or equal to 2 minus 2x is less than 10. And you remember what we're always trying to do in algebra, no matter what weird symbols we get, is get x by itself, right? So usually in these type things, x is in the middle. Almost always it is. If it's not, that's just really strange, okay? If I want x by itself, I want to add or subtract anything I can to get it by itself first. Now, I've got a 2 here, so couldn't I subtract this 2? But if I'm going to do it, I got to do it every single, there's 3 places to do it just instead of 2 this time, right? That's the only thing different about this. Well, one of the different things about these is that you've got to subtract 2 from 3 places. So 3 minus 2 is 1. These add up to 0, so I'm just going to be left with negative 2x because 0 minus 2x is negative 2x. And then 10 minus 2 is 8, right? X is still not by itself, is it? So what do I need to do to get x by itself now? Yeah, divide by what? Let's go ahead and divide by the negative also, okay? So let's divide by negative 2. All 3 places. But I just divided by negative, so what do I have to remember to do? Change the sign. So let me just write it down below it, okay? That's negative 1/2 is greater than or equal to, okay, those 2 cancel out. And 8 divided by negative 2, there's the x. 8 divided by negative 2 would be negative 4, right? Okay. So is x by itself now? Yeah. So we're finally finished. So when we divide by negative, we flip the inequality sign. This isn't wrong, but probably how we would normally see this written. Isn't negative 4 smaller than negative 1/2? So they usually try to write the smallest numbers on the left. So it would be negative 4. Now isn't it pointing at negative 4? So when you translate it over, you still want that little n to be pointing at negative 4, right? That's how I have to think about it because I get them backwards really easily if I'm not careful. And then doesn't the x have this little one pointing at it where I put that little dot? So it needs to stay pointing at the x. So what this is telling me is that my x's are between negative 4 and negative 1/2. If I were to draw a picture of this on the graph, like if here's 0, and you didn't have to do this, I just want to show you what this is telling us. That means I'm not going to count negative 4 because it doesn't have an equal sign under it, right? This thing right here is just a less than. And then my other boundary value is negative 1/2, which is about right here, but it has this line underneath it, which means I'm going to color in that negative 1/2. I'm going to make that a solid dot to show that I can count negative 1/2 as a solution, and my x's are in between there. So that's how I could actually show my solution if I wanted to draw a graph of it. This is one of those things that the book doesn't do, and then you get to Algebra 1 and they assume you know how to do it, so I just want to make sure that we've practiced it some this year, because otherwise you'll be going like, well, we didn't do that. Okay, so this is D. Here's the x. It's not by itself. It helps to circle it. Let me just tell you, your equations get more and more complicated, the further you go through math. This circle on the x can really keep you on track here, because you know that I want to leave alone, and I want to move everything else away from it. Because sometimes it's hard to know, well, am I supposed to move the 17, or am I supposed to move something else? Well, if you get the x circled, you know you're working on that side. What can I do to get x by itself right now? Add 7, right? We want to add or subtract first, because when we're solving, we're thinking backwards on PEMDAS, so we want to add or subtract first. That's opposite of when we're simplifying. So that would add up to 0, and I would have 5x is greater than or equal to, what's negative 17 plus 7? Negative 10. Good. All right, so is x by itself? No. What am I going to do to get it by itself? Divide by 5. On both sides, right? Do it to one side, you got to do it to the other. 5 divided by 5 is 1x, which we're just going to write as an x. Why didn't I flip the sign? Because you didn't divide by negative. Didn't divide or multiply by negative. Some people think they're just supposed to flip the sign, but that only happens when you multiply or divide by a negative. Not when you subtract from both sides. Even that doesn't flip it. On the right-hand side, I have negative 10 divided by 5. What's that going to be? Negative 2, right? Because a negative divided by positive is a negative. So that's what D would look like. Uh-huh. On this one, before we would add 2, we have to kind of simplify the side first before we solve. You remember, anytime you've got something that you can do to simplify, you have to do that first. Remember how you have to go 4 times x is 4x? That's distributing. Have we done that before?
I think you talked about it.
Okay. If you have a number sitting out in front of parentheses, you have to kind of get rid of the parentheses first. So you have to say 4 times x is 4x, and then 4 times negative 2. A positive times a negative is a negative, and 4 times 2 is 8, and then that's greater than 20. So really what we're going to do is what now? Add 8. So we have to kind of get that out of the parentheses first. So I really need to add 8 to both sides. Okay. So if I add 8, those are going to cancel out and add up to 0. So we'd have 4x is greater than 28. Here's x. It's not by itself, so what do I do? Yep, divide by 4. And I would get x is greater than 7. That would be what we'd do there.